Thanks everybody for rejoining. Good to see everyone back here for the top of the hour. We've got, here we go with session 4 of day 2 of the 2025 RNG Technical Symposium. I'm Paul Green. I run a biogas advisory business and I drive the biogas.tv website. In this session, we'll hear from Clarke Energy on their solutions and offerings in the biogas space. Feel free to ask questions on the fly in the chat or the Q&A box, and we'll also spend a few minutes on questions at the end. Later today, you'll get an email from me pointing to the slides from this talk up on my website, and a video of all the sessions today will be available on biogas.tv by the end of the week. So with that, I'd like to introduce Jeff Fotakis with Clarke Energy. Jeff earned his ACS chemistry degree and then focused on waste utilization and biogas upgrading. A notable project of his was the first in the USA to both inject RNG into a natural gas pipeline and fill on-site CNG vehicles, receiving the Project of the Year award from EPA's LMOP program in 2013. In 2022, Jeff joined Clarke Energy as a USA RNG sales manager to grow their biogas processing sector. So with that, Jeff, floor is yours.
Perfect. Thanks, Paul. Let me pull my presentation up here. All right. Can you see my screen with the first intro slide?
Indeed. Yep. We've got you.
Perfect. Perfect. So thank you for the introduction, Paul, and for hosting this symposium. As you mentioned, I'm with Clarke Energy. My name is Jeff Fotakis. I focus on our biogas upgrading and other biogas utilization portions of our business. We're a solutions provider and a leader in distributed energy applications, but have a wide kind of history with projects with integrated biogas utilization solutions. So I wanted to talk today a bit, about doing CHP, doing RNG, CO2 recovery as well, but pairing some of these together sometimes have some wider benefits to a project. So want to talk through some of those a bit. So I'm going to start a step back, and this is probably apparent to everyone, but what is biogas? Biogas is mainly methane and carbon dioxide, in about 50-50 ratio. Digesters tend to be a little bit higher. Landfills tend to be a little bit lower in methane content. There'll be water vapor and other volatile organics and non-methane organic compounds and hydrogen sulfide. But for the most part, you'll just have methane and carbon dioxide. And biogas is biogenic in origin. When a plant through photosynthesis absorbs that atmospheric CO2, and then either you put that plant into a digester or through animal feed or other value chain or food waste, it goes through a digester or a landfill, you'll create biogas. When that biogas is utilized, that CO2 doesn't have any increase in new atmospheric CO2. So something notable to mention that's a benefit with biogas and with also biogenic CO2. So, but that biogas has heat value. It's, roughly a medium BTU gas, 500 BTUs per cubic foot. And, historically, a lot of the earlier biogas projects utilize the gas directly as a medium BTU fuel. An example, you could send gas from a landfill, dehydrate or remove hydrogen sulfide or other treatment, send it next door to somebody who has a need for process heat and has a boiler or a dryer or evaporator. You could generate electricity with that medium BTU gas directly. You could do combined heat and power, so you're capturing the heat from the exhaust of that electricity generating unit. You could put an absorption chiller in coordination with the CHP unit and provide cooling to a process. Or you could separate the methane and the carbon dioxide and raise the BTU value of that biogas to be a high BTU gas, or about 1,000 BTUs per cubic foot, and create renewable natural gas that's interchangeable with regular natural gas that exists in the current distribution network. And then, applications from that, you can make CNG and run compressed natural gas vehicles, make liquefied natural gas. You can use it as a precursor molecule to make green hydrogen or other transportation molecules. It could be, and part of my presentation today is to talk about how some of these solutions can be done collectively together. And a point that I want everyone to walk away with is, I see it as more completely utilizing the biogas when you do CO2 recovery along with utilizing the methane from the biogas, and not looking at biogas is just a place to, utilize some of the heat value, but there is commercial value in the CO2, which is about half of the composition of the biogas. So I'm going to just give a little highlight on CO2. Where does CO2 originate in the world? Obviously, fossil fuel power plants. A lot of CO2 comes from chemical manufacturing world with ammonia production and ethanol production. A lot of industries from cement and steel, pulp and paper, all can produce CO2 as well from their processes. CO2 is a naturally occurring molecule. It's formed in our respiration as we breathe all the time, but it comes from wells in volcanoes, and fires also generate CO2 as well. But more specific to the types of projects that we work on, there's going to be CO2 that comes off of a biogas upgrading process, typically as a kind of an off gas or CO2 stream. And depending on the renewable natural gas processing technologies and how much kind of methane slip exists in that system, you could typically see in the 80s to all the way up to like 99.5% of pure CO2 in that off gas stream. And that can be used beneficially. Also, post-combustion sources. So if you have a CHP project with a reciprocating engine, for instance, if you're using pipeline gas, it tends to be a little bit lower. Biogas tends to be a little bit higher, but 3.5 to 12.5% is probably a good rough estimate on the average that you could see for the CO2 content in the flue gas after combustion, and the bulk of that being nitrogen as well. So then, how is CO2 used? And CO2 has a lot of commercial applications in the world around us. Obviously, it's used in agriculture for a lot of purposes. You could put it into a greenhouse. It exists in a couple hundred parts per million basis already in the atmosphere. But if you increase that to a couple hundred more parts per million in a greenhouse, you'll see a boost in the yield and the production of that greenhouse. You could use it in fumigation, as a fertilizer production, all in agriculture. It's used as a concrete additive. Meat and food processing facilities use it. You produce dry ice blocks or pellets that can be used for cleaning processes or shipping and packing meat products, for instance, or other food products. Obviously, carbonating beverages. We all drink a lot of carbonated beverages, and that will require CO2 to be introduced in that product. Decaffeination uses tobacco industry has a need for CO2. pH control in wastewater facilities, fire suppressant systems, the list goes on. And even sustainable fuel with, creating methane back from the CO2 is another process there's been a lot of development in. So there's no shortage of uses in the world for that CO2 as a commercial product. And then I want to highlight what are some of the states that you'll see the CO2 in. So, obviously you can see it as a gas. You can compress it, liquefy it, or make solid dry ice out of it. If you have gaseous CO2, it's going to have less CO2 molecules per that volume. So, it's usually used more locally on site. If you compress that, it's going to require energy to compress that CO2, but you'll be able to fit more molecules in that same volume and potentially transport it a little more effectively. You could liquefy that CO2, and through liquefaction, have a higher density of CO2 molecules per kind of the same volume of space. And, that's going to require more energy, but allows you to be able to ship that CO2 more effectively. And one thing to note is that the liquid CO2 storage tanks have a tendency to be a little bit higher in cost than what you see out of a gaseous storage. So something to note. Or you could make solid CO2 or make dry ice. And that's going to be the highest density solution in terms of the state the CO2 could exist. You could make, blocks or pellets out of that CO2. And that could be used, directly as a refrigerant or a freezing agent. But something to note is that you'll typically see a loss during this dry ice production. So if you have a certain weight of liquid CO2 and you create dry ice, you're going to end up with 75% roughly. It could be optimized, it could be more or less than that, but of the weight of dry ice to the weight of liquid. So you'll end up with like a 25% loss of CO2 in that process. If you do that on site, you could potentially capture that loss and re-liquefy, so you end up with the same volume. Something else to note is that when you create this dry ice, it's going to sublime to the atmosphere immediately. So you'll have loss is occurring with that. And if you create something like a dry ice pellet that's used for pellet blasting, that needs to be utilized within a certain time frame, or you'll start to see a loss in mechanical integrity and use for that purpose. But these are kind of the from a high level, the different states that you could see kind of CO2 be utilized. And then, what is CO2 purity? Because, every application is going to require a little bit different purity of CO2. Some sources of CO2 are going to be better suited for different applications. I like to describe CO2 as kind of a spectrum of acceptance. People would probably view human wastewater treatment plant CO2 differently than they would food waste digestion CO2 in terms of acceptance in drinking that in their beverage or for some other purpose. So, there's different constituents in those CO2 streams coming from biogas, and, they could be treated, to different grades. Here you can see industrial grade is at 99.5%. That could be vented directly from an RNG facility today. So, to go from that to some of the higher grades, you have medical, food, beverage, or some of these specialty grades, like even research grade, get very pure. It's all in the trace constituents because they're all over 99% pure CO2. And one guidelines kind of that's worth mentioning is this International Society of Beverage Technologists, ISBT. They create a standard that's used and pretty widely accepted worldwide for the CO2 requirements going into beverages. So you can see from the table here, it's not just the purity of the CO2, it requires 99.9%, but there's trace constituent measurements that need to be in place with, sulfur compounds, other volatiles, other nitrogen compounds. But there's also sensory requirements, like it has to have no odor, and it can't have any color and appearance in water or any taste. So there's some requirements associated with that need to be set in to be able to use that CO2, for instance, in beverages. And at the end of the day, end users can set their own standards. Sometimes we've seen, there could be somebody who wants to make dry ice that's saying we want beverage grade just for the assurance that the dry ice or the CO2 itself has been processed well, and it gives assurance. Or, it's a beverage manufacturer might set a standard even higher than what ISBT would set. But this chart here, it has an example of what an kind of integrated biogas utilization flow would look like. And there's, countless examples of how this could be configured. But in this demonstration, there's, manure or other crop residues or food waste go into a digester that goes through some kind of biogas treatment. You can dehydrate, remove hydrogen sulfide and, siloxanes or something else, other volatiles, for instance, and send that gas to a CHP unit. Or you could upgrade the gas and separate the CO2 and make biomethane and transportation or pipeline injection. Also note this: the heat from the CHP unit could be sent back to the digester. The CO2 coming off of the RNG process could be polished and dried and liquefied and concentrated to make a liquid product. So there's quite a few different configurations, but that's an example of one there. I want to go through some of the case studies and some of the projects that we've worked through to highlight some of the benefits in these integrated solutions. So this first project was a peak renewable site in Maine. It's on Flood Brothers Farm. It's an RNG facility with CHP and backup power. In this facility, they have anaerobic digester from several dairy farms. The biogas upgrading was done by another group than Clarke Energy, but we brought to the project the combined heat and power unit and also the backup power system from Kohler, who's our parent company, or Kohler Power Systems, now rebranded Relco. But we brought those pieces of the project because it created some advantage. So there's 280 kilowatts of electricity that's generated from pipeline natural gas, and then 1.5 MMBTU of thermal heat is captured from that CHP unit and then sent back to offset requirements to heat the material and then heat the digester system. So there's a benefit in providing some power to the system and then also some heat to the system. Another configuration that's a really cool project is our site Biotown Biogas in central Indiana. It's an RNG and combined heat and power facility that was commissioned in 22. The biogas upgrading system is about 1,500 standard cubic feet a minute. And we worked with a company, TPI, for the biogas upgrading portion of it. We built the biogas upgrading and that CHP portion of the project, and also operate that RNG plant and have some service arrangements in place. But the pre-treatment system for the renewable natural gas portion of the project was sized larger than the requirements of the renewable natural gas system. So if they have some excess gas generated in the digester, they're able to treat that gas and then send it to the combined heat and power unit. So that CHP unit, which is the Yenbacher J420, generates about 1.4 megawatts of electricity output. That can be operated to run on biogas, natural gas, or a blend of both, depending on what their requirements or what their needs are. There's that flexibility. And then the heat from that CHP unit can also go back and then heat the digester system. You can also use it if you had a project site that wanted to use that heat for, drying digestate material or some other requirement. That heat can be utilized as well. But the renewable natural gas of the project is injected into the natural gas infrastructure. They have a CNG vehicle fueling station on site as well, at that pipeline injection point, which is a really cool addition to kind of a larger integrated approach with their project. And then something to note is that CO2 recovery, if they wanted to add, a CO2 recovery and liquefaction, they could do that to the system without modifying the existing RNG system. And it's a really, really cool project site.
Jeff, can we go back on the CO2 recovery question? We got a wave of questions that came in on use of recovered CO2 in the food and beverage industry, like what is safe for human consumption, what is to be used for more kind of like industrial purposes in the food and beverage setting. So you mentioned the ISBT spec, but in my experience, some beverage companies, depending on your feedstock, just say no to that recovered CO2 regardless of the quality. So how many grades of food and beverage CO2 are there?
Like you said, the offtake or that consumer of that CO2 may just not want biogenic CO2 or biogenic CO2 from a specific source compared to another. So it's up to the end user for that purpose. But for beverage grade use, ISBT sets that standard. They have a kind of ongoing discussions around the sources for those CO2. But you'll have, the FDA regulate, at least from a food perspective, CO2 used in food itself. But any one of these biogas sources could be cleaned to food use or beverage use potentially, if it's both accepted by the controlling body that would set the standard and then the end user itself. I think there's different constituents, as in some of these different a landfill gas, biogas is going to have a lot of potential, from my experience, and a lot more wide range of volatile constituents than what you would see out of some different digester systems. So it's there's potential for different materials to then be in that CO2. So as long as it's gone through treatment systems that it's interchangeable with existing CO2, it's the acceptance by some of those controlling groups, I would say.
Okay. Thanks. It seemed to be a bit of a hot topic. People wanted to dive in a little bit more deeply. What do we do with the CO2 that we're actually recovering? My understanding is the bulk of CO2 comes from the ethanol industry. Fermenting ethanol comes from these fermenters, and you extract your CO2. But doing projects with some things that are truly wastes, like our feedstocks are, I think there's a bit of an ick factor. Sometimes it's hard to kind of navigate around that or go through that. So good to know. Okay, thank you.
Yeah, no worries. I mean, from my perspective as a chemist, if you take that gas through detailed analysis and there are no other constituents in it, you have created interchangeable gas with gas that would have been formed at an ethanol plant. But to your point, I think there is that bit of an ick factor, which I think would extend more or less to different sources of material going into digester systems or where that biogas is generated. So, there might be a better fit for some feedstock waste streams than in terms of the application for the CO2 than others. And, in my mind, if it was material that was fit for human consumption going into a digester system at one point, you're going to see, I would imagine that would have a little bit less of that ick factor would be the point I would make.
Yeah.
So,
Okay, great.
So, and I'm going to have a couple more slides on some CO2, but, at least to hit home on why would you want to add, combined heat and power to an RNG facility, for instance. You can create resiliency for the project by creating energy yourself. If there's, some kind of disaster or an event that would create interruption in the grid supplied electricity, you'll have that available and you're less exposed to electricity rate increases. Also, there could be a potential improvement in the carbon intensity score if the power that you're buying from the grid has less of a benefit, it has less impact beneficially to the environment than the power you would produce on site with using natural gas, or if you would use biogas. Oh, here, sorry. Oh, I lost my presentation here, Paul. Hold on one second.
Yeah, something happened.
Yeah, we get a lot of office updates. Give me one moment. Let me pull it back up. Always have to have a hiccup. Technology.
It's only a test.
Yeah, exactly. All right, let me pull this back up, and my apologies. Okay,
Good
can you see
recovery.
okay, good.
Yeah, you're back.
All right, perfect. So hopefully that won't happen again. But if you're using biogas as the fuel that goes into that CHP unit, that could potentially reduce your carbon intensity score, being that bio CO2 isn't going to increase the CO2 to the atmosphere. But then some other benefits, you could potentially generate some renewable electricity credits or energy credits with using biogas. One point I would note is that if you're going to add CHP to an RNG site, you can design the RNG injection skid or metering and regulation skid to be bidirectional. So in addition to doing, the odorization or pressure regulation or nominating and qualifying, all of what's typically done in that injection skid, you could also pull CHP back out of the pipeline you're injecting into to supply a CHP unit or boilers for that instance to help with the digester. But you could even free up some excess capacity if your distribution line that you want to inject your renewable natural gas is at capacity. That might help shore up some extra space to then be able to inject the RNG. So something else that could potentially be a benefit to a project. So one really cool utilization for CO2 that I want to talk about, because it's something that we've done quite a bit in the past and is a little bit more simplistic approach, is pairing a combined heat and power process where you're making electricity, also making heat, with utilizing that CO2 and recovering that in a greenhouse. So under this configuration, you could treat the flue gas from the CHP unit, which would be, depending on whether it's biogas or pipeline gas, probably somewhere around 5-10%, maybe a little bit higher CO2 in that flue gas. Treat to remove like NOx, carbon monoxide with some systems, and then send that CO2 to the greenhouse. Also send heat to the greenhouse. And this same configuration can be done with a digester and with biogas. So if you have material that's being grown in the greenhouse that could potentially go into a digester system, create biogas from that digester system and pair with the CHP for this same configuration. Sorry, Paul, I lost it. I'm just going to keep talking now. But you can pull up. Sorry. You can use that digester, create biogas, and then use that material to then feed back the heat requirements and the CO2 needs in the greenhouse. I've also seen some potential applications with using a renewable natural gas plant that would then liquefy that CO2 and potentially truck that CO2 to a greenhouse, and that greenhouse could offset a retail cost for them to purchase renewable natural gas as well. So something else that's a pretty cool configuration. It's one of the more simplistic approaches towards biogas utilization with CO2 recovery. All right, it looks like it's updating my Microsoft. I have a PDF version. I'm just going to work off that because hopefully that won't create any more issue. My apologies. Okay. All right, can you see the slide now, Paul?
Yeah, yes, we got you.
Okay, perfect. So one example of this style of configuration is our AGR greenhouse and energy facility that's in the UK. It was commissioned in 2021, and this project is it's fueled on pipeline gas, but as I described, could be configured with biogas, and it increases the CO2 concentration of the greenhouse and the crop yields. And it has 3 Ineo Jenbacher gas engines paired with that CO2 recovery. The project produces 9 megawatts of electrical output, 11.2 megawatts of thermal output, and there's a big heat pump system associated with that. And Clarke Energy, we kind of EPC'd and brought that combined heat and power plant to that project. So, I mean, it's a more simplistic approach towards CO2 recovery, but one that has a benefit to the projects, and then having that CO2 be utilized and not just directly emitted to the atmosphere. Another potential configuration, and one that we're working through, is a quad generation style configuration. And this, we would have gas engines making electricity, also making heat, and then pairing with absorption chillers and making cooling, a cooling refrigerant back for a process, and then taking that exhaust gas CO2, concentrating it, and then cleaning that to where you could make a beverage grade CO2 product. So this is a configuration that we're working through right now. We're building for Liberty Coca-Cola in New York. And it's the first of its kind in the United States, but it's, like I described, making electricity, heating, cooling, and then a beverage grade CO2. It is operating on pipeline natural gas, not on biogas, but this same style of configuration in its technical reality could work with taking wastewater from a bottling process or expired product, putting that through a digester system, having that digester produce biogas, and then that biogas either used in an engine for quad generation and then create the CO2 that can be used back in the product, or do renewable natural gas upgrading and have that CO2 from that process be used back potentially in the beverages. And this project is in place, would meet ISBT and Coca-Cola's internal CO2 standards. The project itself is generating about 1.7 megawatts of electricity, and we were the EPC Clarke Energy for this total process. The kind of last configuration that I want to go through that is one that I think has a lot of potential, is to do biogas upgrading, where you would also then capture and liquefy the CO2. Under this processing arrangement, you can see the biogas that's 60% methane, 40% CO2 goes through some pretreatment systems. This is a 3-stage membrane system that I'm sure a lot of people are very familiar with. Coming out of the second stage will be your product RNG that can be injected into the grid. Out of the third stage, which will add a little bit of recirculation and some extra recovery to the renewable natural gas production, is a CO2 stream that, it's typically about 99% CO2, maybe 1% methane. That stream, is often vented to the atmosphere. Sometimes with a lot of renewable natural gas plants, it'll also go to a thermal oxidizer, but that stream could be then put through the renewable or the CO2 recovery and liquefaction system. So you'll have the CO2 compressed and cooled and go through some polishing and some dehydrating, and then a reboiler distillation step, and end up with a CO2 stream that's 99.6 or above, all the way to beverage grade. Something else I would note is that there's a recovery slip that would come off as a non-condensable gas from the reboiler stage that you can send back into the system. So under this configuration, it's going back in front of the screw compressor in the middle of the RNG plant. But what that would allow is that extra 1% of methane in the off gas to be sent back to be then captured in the renewable natural gas system, functionally adding another stage of recovery to the RNG plant and capturing virtually all the RNG that would be generated from the facility. So it's a pretty cool addition to be able to capture that and also make the CO2 product. So the first project I want to highlight is our Samathan RNG and CO2 recovery plant. This was inaugurated in 23 in northern France. It's an anaerobic digester that takes green waste and biomass and other agri-food industry waste materials and puts that through an anaerobic digester. Clarke Energy, we built both the RNG and the LCO2 systems collectively at this site. They're generating something like 400 normal cubes of methane, maybe 250 standard cubic feet a minute, roughly, and then also 460 kilograms an hour of separated CO2 in liquid form. That could be used and sent off for dry ice production. In the inauguration of this facility, they were making dry ice on site to demonstrate that purpose. And the second facility that I want to highlight is our MD Biogas RNG and CO2 recovery plant. This was commissioned in 2024, early in 2024 in France as well. And this is taking a similar waste stream, mixed waste stream through an anaerobic digester. This system, we worked with TPI to build just the CO2 recovery and liquefaction system. The RNG plant was done with a different supplier than TPI and with was built with a different group than Clarke Energy. So, point to make with this style of facility is, this renewable natural gas process, you can pair CO2 recovery and liquefaction at a later stage, for instance, to an RNG plant, and can be done with, a wide range of RNG processing technologies, all of which typically have a kind of CO2 or off gas stream of different compositions. Most of the time it'll have pretty concentrated CO2. If it's more historically a two-stage membrane system, that amount of methane could be a little bit higher. Some, depending on whether it's a PSA or amine or how many membrane stages or water washing system, any of those out there, they could have H2S or other volatile organics in it. All of that could be treated and addressed to then create a liquid product stream off of that process. And to note that Clarke Energy, we EPC'd the CO2 recovery liquefaction system, also the truck unloading station, and then the liquid CO2 storage, and have a continued service contract with that facility as well. So why would somebody want to add, CO2 recovery to an RNG plant, for instance? Like I described before, there's market demand for carbon dioxide. It's used in many industries. They have seen shortages occur in the CO2 market. And I'll touch on this a bit, but there are government incentives for taking carbon dioxide and storing it in geological formations. And that incentivizes some of those large existing point sources to not sell their CO2 into the market, but instead generate credits that way. And when those shortages have occurred, some of the lower volume customers have been kind of cut off from their CO2 supply first. So, that could avoid the impact of some of those supply chains by supplying CO2 into the market. Also, if you're, one example configuration would be a meat processing facility that uses CO2 for a purpose or dry ice, for instance, to ship their product. If they have waste material, put that through a digester, generate biogas, and make renewable natural gas, and then create dry ice. They could use that dry ice to offset what would be retail price that they're paying for that dry ice today. Could be an advantage for them, especially when the supply chains could be causing a price increase. So also there's monetary benefits. You could potentially generate some additional revenue for the project with CO2 as a commodity. That can diversify the project revenue a bit from depending as much on the environmental attributes as they are without having that CO2 as part of your revenue sources for the project. And like I described before, you could avoid securing your own liquid CO2 or dry ice if that's needed for your internal processes, but also improve that methane recovery. If you have a process that has 10% methane in that CO2 off gas, it's going to be a big monetary benefit to capture that methane and then sell that back into your project as renewable natural gas instead of maybe sending that to a flare or a thermal oxidizer. And then, there are government incentives to help encourage utilization of CO2 with the Inflation Reduction Act's production tax credits through 45Q. If you have qualified CO2 with the prevailing wage and apprenticeship installation, and if it's at 12,500 metric tons a year, you could see potentially $60 a ton for utilization of that CO2, or $85 a ton for storage in geological sequestration. But there's an environmental impact potentially through utilizing the CO2 and doing CO2 recovery. If you're sending that CO2 and in your to a consumer that's would traditionally be using a non-biogenic source of CO2 instead of a biogenic source, that could be an indirect emission reduction, off-site through their use. If you're taking that CO2 and sending it for geological sequestration, that would just make your RNG product more, carbon negative. And then if you are capturing that methane slip and not, sending that potentially as a small slipstream to the atmosphere, there's going to be an environmental benefit towards capturing that CO2 as well, or that methane from the CO2 off gas. So a little bit on Clarke Energy, we approach things doing engineering, installation, and maintenance on projects. We like to provide kind of turnkey approaches or a single hand to hold, for instance, across projects. And then, we like to stick around after we build out a project and see its continued success with kind of maintenance agreements and service or operational agreements with projects as well. And a little bit on our group, we have 1,350 employees across 26 countries. Our global headquarters is in Liverpool, UK, but we build out a lot of local resources where we've opened offices. And I may mention before, but we are part of Relco, a Relco company, which was formerly Kohler Power Systems. And this is a kind of map of all of our global footprint in terms of the offices we have. All right, cool. Paul, I may have run a little long, and especially with the presentation dropping out, but here are my contact details and open to answer some more questions.
Yeah. So that ends the presentation. I am going to keep going with Jeff on some questions. So I think this will be a shorter break. If anybody wants to engage in your break now to come back for the top of the hour's presentation, go right ahead. But I'm going to keep going with Jeff while we have him here. So bunch of questions. What do you think the standalone, what do you think for a standalone CO2 recovery system, what do you think the ROI might be on CO2 recovery?
Yeah, I mean, it's going to depend on, one, the use of that CO2 is going to be a big driver for that. And the CO2 market is very regional. So depending on where your project is and the availability, if you're next to a big ethanol plant, there may be a different availability of CO2 in that local market than if you were somewhere that didn't have that situation. So it, roughly seems to be a little bit higher price on the coasts and a little bit lower price more in the central part of the United States, but that's very regionally driven. And then if you, for instance, sell that for dry ice, you're going to see a lot less return than if you sell that into the beverage market. We'll have multiple times the kind of the revenue that you'll see. And then also on the other end of it, if your processing system for the renewable natural gas is a 3-stage membrane system that has 99.5% pure CO2, that's a little bit less processing that's going to need to be required to make whatever product you're making in the end. So, I think what we've seen is that if you have say for instance, like a dairy or another kind of digester project that's making dry ice, we've seen that, and depending on the scale also, but we've seen it to where it'll be a couple year payback. So something that's still advantageous to add on to a project site.
So a question here, what are the major challenges that hinder facilities from implementing a CO2 recovery system to their plant? Is it CapEx, OpEx, process compatibility? I mean, one I'll lay in is suddenly you're in the CO2 business and not everybody
Yeah,
wants to be in the CO2 business where
yeah.
the long-term offtakes suddenly aren't there sometimes. So you've got to be doing the regular blocking and tackling of selling your CO2. But what else might you add here, Jeff?
Yeah, I mean, I would say that's one of the biggest contributors, Paul, is that, it's still a bit of an analog industry. So, you're not going to get a term sheet by making a phone call to a broker as easily with this style of offtake. If you can find a user that in your local area that is consuming CO2 that you can offset their retail price, that's kind of the attractive path to finding an offtake, and it's something that requires a hands-on approach a little bit more than something like renewable natural gas has become such a developed industry at this point that it's more straightforward in getting some of those offtake arrangements in place. But there's like you said, some of these regulatory bodies and their acceptance for some of these still have some guidance pending that is going to give a little bit more clarity, and that doesn't help with some gray area and whether or not you could use this potential source from a digester for beverage use or that. So that definitely is a hurdle and something that we're expecting to see some clarity on.
Can you speak to energy consumption for CO2 recovery? The question here is about the project energy balance. Does the CO2 recovery make sense from a pure energy usage and energy balance perspective?
Sure. Yeah. I mean, I will say from a high level, the CO2 recovery and liquefaction is going to be a consumer of electricity. I know I'd have to pull up the figure per kilogram of CO2 processed. I don't have it memorized in terms of the absorbed power that's required, but we see that it's a less intensive process than what you'd see. For instance, if you're going to do CO2 recovery and liquefaction on a 3-stage membrane plant, it's going to be a lot less power than the RNG process itself, a fraction of that power. So, I'd have to go back in my math and calculate, but I think off the top of my head, I want to say roughly in that configuration, something like a fifth of the power that's required. But that's all going to be dictated a bit too on, the RNG requirements for pipeline injection if it's higher pressure. So, but it's, something that we're happy to answer in more detail. Hopefully that answers a little bit.
This section 45Q tax credit. So would people have needed to have safe harbored the project by 1 January to think about 45Q, or is it too late to think about 45Q now?
Obviously something that you'd have to talk with a tax expert on. Clarke Energy, I will preface, is not a tax expert. Something that would need to be done when people file their own taxes as an entity. But from my understanding, the production tax credits do continue on, and 45Q, I believe, is through the end of 2030 or 2032. I'd have to go back and verify. But worth communicating with your tax experts, but this is not part of the incentive tax credit. It's part of the production tax credit. So it has continuing efforts moving forward for several years.
Can you delineate between carbon capture of a high concentrated tail gas versus a post-combustion gas?
Yeah. I mean, it's going to require.
Is it productive to look at exhaust gas for CO2 recovery that's lower concentration?
It depends on how much you need that CO2. Obviously, Coca-Cola, it's very integral to their product, or other potential users that could generate waste or need that CO2. It's going to be more costly to not just do the liquefaction and bit of polishing and cleaning of that CO2, but to do the concentrating all the way from 10% roughly to 99% or higher, is going to be another stage that's going to require a whole nother processing train and going to add cost to the project. So, off the bat, if you start with CO2 that's 99% pure, you're already halfway there in that style of example. So it's going to be a cost to add, and something that can be done with amine systems are typically the approach, and a lot of times to concentrate that flue gas stream. But there's also some people out there looking at membrane solutions, and there's some existing PSA technologies out there that could make it a little bit more cost effective than doing a full amine system. But there are, several approaches there to still capture the CO2 post combustion, but it is more intensive of a treatment process.
Okay, let's call that good. A lot of pent-up demand here to want to talk about CO2 recovery. So any other unanswered questions, reach out to Jeff directly and he'll take good care of you. So Jeff, I want to thank you. Very excellent presentation. Clarke's a great brand name, and people should give you a shout if there's anything there that they want to talk to you about. So we'll let you run, Jeff. Thank you again. And so for the guests, we've got a 15-minute break. Top of the hour, Guild is going to talk to us about dry media treatment for things like gas conditioning, gas desulfurization. So look forward to hearing from Guild here in about 15 minutes. So Jeff, we'll catch you later, buddy.